We're live. Voice of Persona ASMR is live. First time stream. How is everyone doing tonight? It's good to see all of you. Welcome to my first ever live stream. I am going to be whispering some facts about space and the universe. And so I think that it's going to be a lot of fun. I don't know how many people are actually going to tune in, which is why I wanted to do a facts video. But we will learn and have fun regardless. So, I think that I will just begin and get started while people trickle in, if any at all. And for those of you who can't make it, I will leave this video up. I might download it and splice it together to cut out some stuff, or I might just leave it up. We'll see what happens. But if you can't make it, don't worry. You'll be able to rewatch it on YouTube anyway, so it doesn't really matter. But yeah, I've got some stuff pulled up already that we can begin looking at and get started with. So let me swap over here. And I figured it would be cool to kind of start with a general overview of the universe. You know, kind of like just read through a Wikipedia article. Admittedly, but it would be rude of me not to do a thorough overview of the universe. We can do that first. And then we can go into more of the sort of, you know, as you can see, I have them up here, more of the more wild facts, because a lot of times these articles, they pull sorts of crazy facts with no context. So I figured that it would be helpful for us to kind of just get an overview of everything that space and the universe entails. So yeah, without further ado, let us begin. There's no need to dilly-dally. So the universe is all of space and time, and their contents, including planets, stars, galaxies, and all their forms of matter and energy. The Big Bang Theory is the prevailing cosmological description of the development of the universe. According to the estimation of this theory, space and time emerged together 13.799 billion years ago. And the universe has been expanding ever since. While the spatial size of the entire universe is unknown, the cosmic inflation equation indicates that it must have a minimum diameter of 23 trillion light years, and it is possible to measure the size of the observable universe, which is approximately 93 billion light years in diameter at the present day. Welcome, it's 47 Nut. Happy to have you here. Thanks for joining. Since I was little, I was always curious about space. I know for a fact there's more life out there than just us. The universe is big and always expanding. And very true, very true. I always like to go back and forth and debate with myself and other people, in fact, about, you know, is there life in the universe? And I think there's definitely life. I think the debate comes from the fact that, like, is there intelligent life? Like humans, you know, is there sentient, intelligent life out there? I think that's where a lot of people are like, I don't know about that, but I tend to agree with you that it's almost like, how could there not be with how large the universe is? And by the way, if you guys have any sort of issue with the mic quality, the volume, just let me know and I can adjust. The earliest cosmological models of the universe were developed by ancient Greek and Indian philosophers and were geocentric, placing Earth at the center Over the centuries, more precise astronomical observations led Nicholas Copernicus, that's a cool name, to develop the heliocentric model with the sun at the center of the solar system. In developing the law of universal gravitation, Isaac Newton built upon Copernicus's work as well as Johannes Kepler's laws of planetary motion and observation by Tycho Brahe. I don't know if I said it right, but let's just roll with it. Further observational improvements led to the realization that the sun is one of hundreds of billions of stars in the Milky Way, which is one of a few 100 billion galaxies in the universe. Many of the stars in a galaxy have planets. At the largest scale, galaxies are distributed uniformly and in all directions, meaning that the universe has neither an edge nor a center. At a smaller scale, galaxies are distributed in clusters and superclusters, which form immense filaments and voids in space, creating a vast form-like structure. I think there's an ambulance going by. I hope you guys can't hear it. This is the struggle of live streaming. I can't cut stuff out. Discoveries in the early 20th century have suggested that the universe had a beginning and that space has been expanding since then at an increasing rate. According to the Big Bang Theory, the energy and matter initially present have become less dense as the universe expanded. After an initial accelerated expansion called the inflationary epoch at around 10 to the negative 32 seconds, and the separation of the four known fundamental forces, the universe gradually cooled and continued to expand, allowing the first subatomic particles and simple atoms to form. Dark matter gradually gathered, forming a foam-like structure of filaments and voids under the influence of gravity. Giant clouds of hydrogen and helium were gradually drawn to the places where dark matter was most dense, forming the first galaxy stars and everything else seen today. From studying the movement of galaxies, it has been discovered that the universe contains much more matter than is accounted for by visible objects, stars, galaxies, nebulas, and interstellar gas. This unseen matter is known as dark matter. Give me 1 second, guys. I'm going to shut my window so it's a little bit less noisy. About the universe. Take my glasses off. I like to put them on because I can read chat better, but I don't need them at the moment. So, the Big Bang model accounts for observations such as the correlation of distance and redshift of galaxies, the ratio of the number of hydrogen to helium atoms, and the microwave radiation background. The initial hot, dense state is called the Planck Epoch, a brief period extending from time 0 to 1 Planck time unit of approximately 10 to the negative 43 seconds. During the Planck Epoch, all types of matter and all types of energy were concentrated into a dense state, and gravity, currently the weakest by far of the four known forces, is believed to have been as strong as the other fundamental forces, and all the forces may have been unified. Since the Planck Epoch, space has been expanding to its present scale, which is where we are now, with a very short but intense period of cosmic inflation believed to have occurred, with the first 10 to the negative 32 seconds. This was a kind of expansion different from those who can see us around us today. Objects in space did not physically move. Instead, the metric that defines space itself changed. Although objects in space-time cannot move faster than the speed of light, this limitation does not apply to the metric governing space-time itself. This initial period of inflation is believed to explain why space appears to be very flat and much larger than light could travel since the start of the universe. And by the way, guys, I will be whispering, but periodically I'll swap back and forth between whispering and soft speaking. I myself like the contrast between whispering and soft speaking, so hope you guys like it too. But there's a lot of like scientific mumbo jumbo here that we can kind of go through, but I have some more fun articles queued up as well that we can look to. But before we do that, we kind of see like a little timeline of our sort of like progress billions of years ago. Vertebrates, multicellular life, photosynthesis, of course, single-celled life, water, accelerated expansion, matter-dominated era, reionization, I've never heard of that before, and then the Dark Ages. But we, I think we've got ourselves a nice little background, nice little introduction to the universe, and we can kind of like move on to something a little bit more fun and sensational, I think. Now that we've got the introductory stuff out of the way, let's get started with something a little bit more sensational. The universe is so vast, it's extremely difficult to know the full extent of its complexities. Humans can only scratch at the surface of its immensity, but whenever we do pick up remarkable information and images, which are awe-inspiring and baffling in equal measure, what we do know has been made readily available to the public, thanks to the leading space exploration organizations. So, here are 20 of the most intriguing facts for your reading pleasure. I think there was supposed to be an image here, but it didn't load for some reason. Interesting. We'll never know, I guess. When you look into the night sky, you are looking back in time. And I would try to find articles that were a little bit more descriptive, just so that they can, explain what they're talking about. But this one is a cool little fact because basically what it's getting at is that time, light takes some time to travel, right? So when we're looking at the sky, the amount of time it takes the light to get to us, we're already looking at it from the past. But I'm sure they'll explain it better than what I just said. So, the stars we see in the night sky are very far away from us. So far, the starlight we see has taken a long time to travel across space to reach our eyes. That's basically what I was saying. In a less eloquent manner. This means whenever we look out into the night and gaze at stars, we are actually experiencing how they looked in the past. For example, the bright star Vega is relatively close to us at 25 light years away, so the light we see left the star 25 years ago, while Betelgeuse, pictured in the constellation of Orion, is 650,000 light years away. So, the light left the star around 1370, during the time of the 100 Years' War between England and France. Other stars we see are further away still, So we are seeing them much deeper in the past, which I think is a neat little thing about science and the universe. And I think the same thing, if I'm not mistaken, I think the same thing goes for sound. You know, I know that we had broadcasted some music in the, I think it was the 70s. Was it the 70s or the 80s? We broadcasted some music, and we, with the intention of kind of like communicating with alien civilizations. You know, let's send some of our music out there. And by the time these civilizations get our music, if they ever do, it would be, you know, the music would be very, very old. For example, you know, they might be getting it now. And, you know, obviously music has changed a great deal since then. So things like that I find very, very fascinating. The Hubble Telescope allows us to look back billions of years into the past. The Hubble Telescope enables us to look towards very distant objects in the universe. Thanks to this remarkable piece of engineering, NASA has been able to create some incredible images, one of which is the Hubble Ultra Deep Field, created using images from the telescope from 2003 and 2004. The incredible picture displays a tiny patch of sky in immense detail. It contains 10,000 objects, most of them young galaxies, and acts as a portal back in time. In one picture, we are transported 13 billion years into the past, just 400 to 800 million years after the Big Bang, which is early in terms of the universe's history. You can watch the Big Bang on your television. For some reason, these images are queuing up. I have no idea why. What is the deal here? I want to see the images, you know? Or are they just not gonna... Okay, well, I was worried it was gonna like be like porn or something for a second. That would be bad. Stream taken down immediately. That'd be the end. You can watch the Big Bang on your television. Yeah, you can apparently. Cosmic background radiation is the afterglow and the heat of the Big Bang, the momentous event that kick-started our universe 13.7 billion years ago. The cosmic echo exists throughout the universe, and amazingly, we can use an old-fashioned television set to catch a glimpse of it. When a television is not tuned to a station, you can see the black and white fuzz and clackling white noise. Around 1% of this interference is made up of background radiation, the afterglow of creation. I never knew that, so put my glasses back on. I'm like an old man. I can't see chat. Hi Hector. Welcome. Thanks for joining me. I hope everything's going well in Mexico. Hope everything is going well and that you're staying safe. We're just reading some facts about the universe. We had a little bit of an introduction earlier in the stream where I read through some facts, or kind of like an overview of the universe, and then we kind of transitioned to more of an extreme, or I would say a sensational overview of the universe. It's more fun, is what I'm trying to say. But welcome, thanks for joining. Again, like I said, guys, if the mic quality is a little bit loud, a little bit low, let me know. I can adjust. It's not a problem. Let me take a sip of my coffee. Hold on one second, please. Nice. Okay. There's a giant cloud of alcohol in Sagittarius B. Sagittarius B is a vast molecular cloud of gas and dust floating near the center of the Milky Way, 26,000 light years from Earth, 463 billion kilometers in diameter, I think. Don't blame me, blame the American education system. And amazingly, it contains 10 billion liters of alcohol. The final alcohol is in the cloud is far from the most flavorsome tipple in the universe, but it is an important organic molecule which offers some clues about how the first building blocks of life-forming substances are produced. And by the way, this is kind of an aside. It's kind of related to the universe, kind of, but not really. One of my favorite conspiracy theories is, and we can do this because it's a stream, so who cares, right? One of my favorite conspiracy theories is that it's not the pyramids, but it's like aliens came to Earth and they combined their genetic information with ours, and that kind of sped up the process of evolution. I don't even remember where I heard this theory, or if I just made it up in my mind, but you know, I think it's one of the most interesting conspiracy theories, because I always think about, like, why is it that we've got, you know, monkey voice of persona and not, you know, tiger voice of persona, you know, like why the apes and not the you know, the other life forms on this planet? Why did we get blessed with sentience and intelligence? You know, obviously, like, dolphins are intelligent, but they can't talk. Squids are intelligent, but they don't build skyscrapers. You know what I mean? So, just that. I was thinking about that. Anyway, that's an aside. There's a planet-sized diamond in Centaurus named after a Beatles song. Astronomers have discovered the largest known diamond in our galaxy. It's a massive lump of crystallized diamond called BPM 37093, otherwise known as Lucy, after the Beatles song Lucy in the Sky with Diamonds, found 50 light years away in the constellation of Centaurus. Lucy is about 25,000 miles across, so much larger than planet Earth. That is the incorrect version of then, by the way, so this article is slowly losing credibility. Not to be that guy, but I'm just saying, you know, use the right form of then. Just please. This is not correct. This is not correct. I digress. And weighs in at a massive 10 billion trillion carats. I never understood why, like, want to change my life right now? Oh, wow. Guys, should I change my life? I don't know. Maybe not. I wish that these websites wouldn't put like 1,000 ads on the video, but it takes 225 million years for our sun to travel around the galaxy, whilst the Earth and other planets within our solar system orbit around the sun. Let me move this up a little bit here. The sun itself is orbiting around the center of our galaxy, the Milky Way. It takes the sun 225 million years to perform a complete circuit of the galaxy. The last time the sun was in its current position in the galaxy, the supercontinent Pangaea was just about starting to break apart, and early dinosaurs were making an appearance. Our solar system's biggest mountain is on Mars. Here we go. The pictures don't load, but the ads do, which is weird. Olympus Mons on Mars is the tallest mountain on any of the planets of the solar system. The mountain is a gigantic shield volcano, similar to volcanoes found in the Hawaiian Islands, standing at 26 kilometers tall and sprawling 600 kilometers across. To put this into scale, this makes the mountain almost 3 times the height of Mount Everest. Uranus. I'm so mature. Uranus spins on its side with some rather strange results. That's probably why we started calling it Uranus, let's be honest, because people are too immature to handle it. Who knows? Most of the planets in the solar system spin on an axis similar to the sun's. Slight tilts in a planet's axis causes... What the hell is this sentence? Most of the planets in the solar system spin on an axis similar to the sun's. Slight tilts in a planet's axis causes seasons as different parts become slightly closer or further from the sun during their orbit. That's better. Uranus is an exceptional planet in many ways, not least because it spins almost completely on its side in relation to the sun. This results in very long seasons. Each pole gets around 42 Earth years of continuous summer light, followed by a wintry 42-year period of darkness. Uranus's northern hemisphere enjoyed its last summer solstice in 1944 and will see in the next winter solstice in 2028. Yeah, it's gonna happen. It's gonna happen. A year on Venus is shorter than its day. A year on Venus is shorter than its day. What the hell does that mean? Venus is the slowest rotating planet in our solar system. So slow, it takes longer to fully rotate than it does to complete its orbit. This means Venus has days that last longer than its years. It's also home to one of the most inhospitable environments imaginable, with constant electronic storms, high CO2 readings, and it's shrouded by clouds of sulfuric acid. And I always thought it was interesting how, like, basically, when you really think about it, humanity evolved around all these factors that our environment possess. You know, all these attributes. You know, the day-night cycle. All of these things. Like, we evolved. Imagine if we lived on a planet where a day lasted a year. How different our evolution might be. It's just interesting to think about those things. So, neutron stars are the fastest spinning objects known in the universe. Neutron stars are thought to be the fastest spinning objects in the universe. Pulsars are a particular type of neutron star that emits a beam of radiation, which can be observed as a pulse of light as the star spins. The rate of this pulse allows astronomers to measure the rotation. The fastest spinning known pulsar is the catchily titled PSR J1748244-680, which has an equator spinning at 24% of the speed of light, which translates to over 700,000 kilometers per second. An artist's impression of what it might look like is pictured above. A spoonful of a neutron star weighs about 8 billion tons. Neutron stars spin incredibly quickly and are also incredibly dense. It is estimated if you could collect a tablespoon of matter from a center of a neutron star, it would weigh about 1 billion tons. 1 billion. 1 billion. The Voyager 1 spacecraft is the most distant human-made object from Earth. The Voyager program launched 2 spacecraft, Voyager 1 and Voyager 2, in 1977. The probes explored the planets and moons of the outer solar system over several decades and are now continuing their mission to travel through the heliosphere at the edge of our solar system, and continue to voyage into interstellar space. On March 20th, 2013, Voyager 1 became the first human-made object to leave the solar system and is now the furthest human-made object from Earth. Currently, 124.34 astronomical units away. In layman terms, this means it's around. Oh yeah, this is layman terms. 1.5581251 1,010 miles away. Putting it mildly, this is a long way from home. Layman terms, of course. Layman terms. I hope you guys are doing well, by the way. Hope everything is going good for you on this Sunday afternoon, maybe evening, depending on where you are. Happy to have you here. Thanks for joining. Voyager 1 captured the most distant photograph of Earth, and we can't see the photograph, unfortunately. I wonder how old this article is that all of these pictures are not queuing up. Let's see here really quick. It doesn't say. Does it? No, it doesn't. Okay. Interesting. Okay. What can you do? Let's go back down to where we were, shall we? In 1990, as part of the spacecraft's ongoing mission, Voyager 1 turned its camera back on our home planet and took a picture. This became known as the pale blue dot. Seen from 6 billion kilometers away, the Earth appears as a tiny blue speck in the depths of space. Astronomer Carl Sagan, who first suggested the idea of the photograph, noted, "From this distant vantage point, the Earth might not seem of any particular interest, but for us, it's different. Consider again that dot. That's here. That's home. That's us." And by the way, guys, really quick before we continue, I don't know if you guys want me to do this instead and do full screen, and I can just read the facts. If you guys have a preference, let me know in the chat. Thanks, Hector. I appreciate it. But yeah, if you guys prefer full screen, I can just read the facts off on my own. I realize that the white sort of background can be a little bit jarring, so I can just switch to full screen and just read the facts like this. If you guys want that, let me know. It's all good. Whatever you want, we can roll with it. I don't have a particular preference myself, so it is up to the viewers to decide. Up to the viewers. I wanted to share my screen because I thought there was going to be cool images and stuff in these articles, but they're not loading, so that's the thing. So maybe we do, Awesome. Okay, cool. If there's no preference, then I'll do it like this, and if there's like cool images, I'll share my screen. We can go back and forth, depending on like what makes sense at the moment. So awesome. That sounds good to me. If I see cool images, I'll just share my screen, but right now it's just white space, so there's really nothing for you guys to look at, so you'll just have to look at my face. Scientists are looking for evidence of extraterrestrial life on Earth. The search for extraterrestrial intelligence is a project to discover whether intelligent life exists elsewhere in the universe and how we may contact extraterrestrial species. The search includes looking for life on other planets and moons. For instance, some of Jupiter's moons, such as Io, I think it's pronounced Io, it's Io, are promising places to look for evidence of primitive life, but the search for extraterrestrial life includes scientific research on Earth. If scientists can discover evidence life has generated independently more than once, it would suggest life could occur in more than one place for more than one time. For this reason, scientists are searching for evidence that life could have happened more than once on Earth, with intriguing prospects for the universe as a result. And that's another one of those like theories that hello, okay guy fam, I can't see, I'm blind. Welcome, thanks for joining on this Sunday afternoon. I was gonna say, that's another one of those like theories that I find endlessly fascinating, is this idea that there was life on Earth before humans, and then then it was, it wiped itself out via whatever happened, some natural disaster. Who knows, right? Like intelligent life, not dinosaurs. And then the Earth went through that period of cooling, and then everything restarted again. And I apply that theory to Mars as well. Like, what if Mars had intelligent life, and then it just kind of like, died out for whatever reason, and then over time, it restarted and then died out again, restarted and died out again, and here we are. Mars is a barren wasteland. It's a fascinating theory, I think. So I like to play around with these things because if you think about how fast and how long existence, when you try to measure existence in terms of years, billions of years, we are just a blip on the radar. So it's interesting to think about like what life was like, and what potentially could have happened. Hello, how to press. Let me turn my monitor here so I can actually see properly. Hi, I haven't watched you since the Dragon Ball Z Facts video. Awesome. Well, welcome back, my friend. Welcome back. It's good to see you. I hope it wasn't something I said in the Facts video. I've never streamed before, right? So I figured that I would try to stream because YouTube seems to like to fuck me with the algorithm, It doesn't like to promote me in suggested videos, and like even my subscribers. I have almost 4,000 subscribers, but most of them do not get notified. And I know that there are people that subscribe to channels and they just don't ever watch those videos again. I'm guilty of being that person. I do that, admittedly, but there's got to be a portion of my subscriber base that they just never see my videos and they totally forgot about me, because I'm not promoted. So I figured I would start streaming, test it out with a little, facts video, some space facts, some universe facts, and see what happens. And depending on how many people show up, we can, adjust the stream for next time. I can do different things, with more interaction. It really depends. Because of the fact that this is ASMR, it's going to be different from a regular live stream, where there's more interaction. People might want to just relax and put me on in the background and go about their tasks, so by default, I think ASMR live streams would have less interaction. So, but this is my first ASMR stream, so we'll see. But anyway, let's continue. Our sun is essential to us, the center of our solar system, and our source of light and energy. But it is just one of many, many stars that make up our home galaxy, the Milky Way. Current estimates suggest that there are around 400 billion stars in our galaxy. The artist's concept above shows what a dusk disk around a baby star could well look like. And the image isn't loading, so let me see if I can get this image to load. No, not really. It's just a picture of space, so it's not really anything weird. But there could be 500 million planets capable of supporting life in our galaxy. And this is what we were talking about at the beginning of the stream, right? Scientists believe that 500 planets could have life, right? That's a lot. That's a lot of planets. Imagine if like at least 1% of those had intelligent life, or 10%, right? 10% of 500. That's 5 planets. That's 5 intelligent civilizations. That's crazy, right? We're debating on whether or not there's even one other intelligent civilization in the universe. So, I figured that how to press. That's kind of how YouTube operates. It changes its algorithm kind of on a whim, and it's hard to know like what works and what doesn't. But from what I understand right now, live streams are all the rage. So here I am. At least I can kind of remind my subscribers, like, hey, I'm still here. I'm still making videos. Don't forget about me, please. But yeah, so 500 million planets are capable, potentially, of supporting That's our galaxy. That's not even considering other galaxies outside of the universe. Scientists searching for extraterrestrial life on Goldilocks planets. These are planets which fall into a star's habitable zone. Planet Earth seems to have exactly the right conditions for life to exist. Its distance from the sun means the temperature is right. The water can exist as a liquid, solid, and a gas, and there are the right combination of chemical compounds available to build complex life forms. Other planets thought to have similar features are known as Goldilocks planets. In the Milky Way alone, there are estimated to be 500 million potential Goldilocks planets. So if life can exist in places other than Earth, there's a huge number of potential planets. Sorry about that. Potential planets on which it might thrive if these numbers are applied to all the galaxies in the universe. There could be a staggering variety of planets capable of supporting life. Of course, we have no evidence life exists elsewhere, but if it does, there are plenty of places for it to set up home. And I think it's very arrogant, to assume that there are no other intelligent civilizations besides humans. It's very, very arrogant to say that, like, we're so special. There's no one else, just us, just monkeys on this planet. Despite the fact that even on Earth here, we have dolphins, squid. They have been shown to possess some level of intelligence, so we know it's possible. It's just different from ours, right? I was listening to Joe Rogan's podcast the other day, and he had a guest on who, I forget the guy's name, but he makes like sci-fi movies and films, right? And he was saying, like, we have intelligence on Earth aside from humans right now. Dolphins, squid, even like ants, bees, right? Bees build beehives and all of these fancy, intricate constructs. And it just makes you think, like, well, what is the definition of intelligence, right? It's like, well, we say we're intelligent, but these other living things are existing and surviving just like we are. We're just doing so much more extra to survive when you think about it. And in a way, that's actually kind of stupid, right? It's like dolphins are surviving just like us, except they don't have skyscrapers and they don't have computers and they don't have, all of these fancy gadgets. But at the end of the day, the end result is the same. Dolphins exist, we exist. So we're just, in a way, we're doing, 100 times more than dolphins are just to exist on this planet. So that's my aside there. There are probably more than 170 billion galaxies in the observable universe. Different calculations provide different numbers for how many galaxies there are in the observable universe. That is the part of the universe we can see from Earth with our current technology. There may be many more, but they are simply too far away for our telescopes to detect. Using data from the Hubble Telescope, astronomers have calculated that there are likely to be around 170 billion galaxies in the observable universe. So, let's think about this for a second, right? 170 billion galaxies in the observable universe. And we think there might be potentially 500 million planets capable of supporting life in our galaxy, right? So our galaxy, I almost flipped you guys off. Our galaxy, and 100 million other galaxies, right? 500 million planets potentially in our galaxy capable of supporting life. That is, I'm not good enough at math to do that, I'm not going to do that equation there, but you get my point. That's a lot of potential opportunities for intelligent life to exist. So, apparently water bears are the first animals to ever live in space. Well, that's awesome. I didn't actually know that. Water bears. Very cool. And what was the first animal that was sent to space? Actually, let me look that up, because I know that first animal sent to space was it? It was a dog. That's right. That's right. Okay, so dog Laika, the first animal to make orbital space flight around Earth. Let me show you guys what she looks like really quick. I'll share my screen here. Check this out. This is a nice little aside. Laika was a young, part Samoyed terrier found as a stray in Moscow. She was chosen as the Soviets. I lost my place here. Soviet scientists believed a homeless animal would be better equipped to endure the cold, hunger, and harsh conditions of space travel. Oh, that's sad though, she died. Inadequate oxygen and food supplies. Look how cute. Yeah, Laika the dog. Yes. I don't have timestamps, but I think you beat us to it, Hector. Laika was the first dog that went to space. How cute. Look at the snoot. Look at the snoot. That's adorable. Fruit flies were also sent to space. And then a variety of animals too, like ants, cats, frogs, and even jellyfish. Yeah. Boris would be proud of this. Yes, I am very proud of this. First dog went to space, Soviet dog, very strong, very sturdy. A total of 32 monkeys have flown in space. These species include Rhesus macaques, I have no idea how to say that, squirrel monkeys, and pigtail monkeys. Chimpanzees have also flown, so that's pretty cool. Albert II was the first monkey in space. Yeah. First animal to orbit the moon. Look at that. Felicity, the first cat in space. That's adorable. It's adorable. I mean, it's all sad, right? Because you kind of get an idea of how it ended, but it's adorable at the same time. The first animals to orbit the moon and return to Earth were two Russian tortoises aboard Sonde 5 on September 1968. The tortoises were launched with plants, seeds, and bacteria around the moon and returned to Earth 7 days later. I'm glad that they survived. But yeah, a lot of different animals went to space. Even a spider went to space, so neato. How does space affect animals? Space can affect animals in many different ways. The early space travel was used to examine how radiation would act on organic matter outside of Earth's protective magnetic field and atmosphere. Nowadays, many space research missions involve examining how animals react and learn behaviors in microgravity. An example of one of these experiments was with caterpillar moths aboard Space Shuttle Columbia in 1982. The moths that were born on Earth and sent into space were unable to control their flight in microgravity conditions and were so clung to interior surfaces. However, the moths that were born in space managed to float and fly, sometimes even making controlled landings. I also think they sent mice into space at some point. I think it was mice or hamsters, I don't remember, but they were, what happened was they were running on their little treadmill thing, whatever it's called, I forget, and they just wouldn't stop. They just kept running and running and running and running and running while they were in space. So interesting to see how that affects different life forms. All that to say is we're not meant to be in space, right? We're meant to be on Earth, but still, that should not stop us. Very cool. Let us resume what we were doing, shall we? There could be an infinite number of universes. That is, this is more a speculative theory than a fact, but several branches of mathematics, quantum mechanics, and astrophysics have all come to similar conclusions. Our universe is just one of many, and we actually exist in a multiverse. There are different ideas of how this could be, one being the concept of atoms, only capable of being arranged in a finite number of ways in time and space, ultimately leading to repetition of events and people. Other theories propose bubble or parallel universes and brain worlds that hover just out of the reach of the dimensions we experience. Although these concepts seem like far-fetched ideas of science fiction, they are actually proving to be the most elegant solutions to problems thrown up by our discoveries of how the universe works. The human brain is the most complex object in the known universe. Our brains are remarkably complex, with 100 billion neurons, a quadrillion connections, and we still know very little about this how this organic supercomputer operates. But we do know the human brain is the most complicated thing we have yet discovered. It gives us the power to form language and culture, consciousness, the idea of self, the ability to learn and understand the universe and reflect on our place within it. We even have an inbuilt model of gravity, which is pretty. I've heard that the Earth will end in 7.5 billion years. 7.5 billion. Well, I don't know about the exact date, but what I do know from the top of my head is that the sun, our sun, is expanding, as all stars do. Each star has a life cycle, and eventually it will die. It'll explode and become a white dwarf. Let me look this up real quick, but it'll become a white dwarf, and in that process of our sun dying, obviously our Earth will go along with it, right? So it is within our best interest to kind of expand into the universe, because if we don't end ourselves first, the universe will do it for us. Like, we have a limited shelf life. It's basically us racing to exterminate ourselves before the universe does it, as far as I'm concerned. But let's see, current lifespan of Earth's sun. Let's see. Yep. So, how to press, you're actually correct. It's 8 billion years, so 7.5, 8 billion, basically the same thing, right? So there's 8 billion more years left until the Earth kind of kicks the bucket. You would think that we would expand before that, because 8 billion years is a long time. Look how much we've accomplished in just 2,000 years, but who knows what's going to happen, right? It's hard to say, but let's take a look at our sun for a second here, and I'll share my screen. Let's see here if we can. This is pretty cool. I've actually never looked at this, but this is our sun here. Can we zoom out properly? We can. This is a pretty neat little chart here, or not even chart. It's kind of just like it's almost like Google Earth for space. But here's our sun. We can look at our solar system as well, right? So here's our solar system in all of its glory. Here's our solar system in all of its glory. Oh no, I have to cough. I'm gonna mute myself. Hold on a second. Oh my lord. Okay, I'm good. Wrong pipe. Okay. So here we are, right? It's pretty trippy, isn't it? But I figured this would be cool to look at. Let's Can we zoom in on Earth? We can. This is a cool little thing. I've actually never looked at this before, but this is cool. So this is our Earth. This is where we live. This is us. We live here. All of us. Some of us might not think we live here, but we do. So our Earth is currently at 4.5 billion years. Our star type is a yellow dwarf currently. Let me zoom out a little bit and go back to our solar system. Go back to our sun here. This can be a nice little tangent where you can kind of just look at different planets that we have. So our current sun is 230 million Earth years. But yeah, it looks like there's more. But yeah, I wanted to see what a white dwarf looks like as well. If I can look it up really quick. Let's see here. White dwarf. Let's take a look. Is this what a white dwarf looks like? It seems to be what it would look like. But I digress here. Let me go back for a second and see. Let's take a look at Mars really quick, shall we? Here we are. Let's take a look at Mars. Let's see Mars. Here we are. This is Mars. Dusty, cold desert world with a very thin atmosphere. There is strong evidence that Mars was billions of years ago wetter and warmer with a thicker atmosphere. It's got 2 moons, named after the Roman god of war. It is, 1.88 Earth years is the length of a year. I was gonna say it's 1.88 years old, which would not make any sense at all. But we can look at the Martian system as well, if we want to. So here we are. It's very cool. But yeah, this is a whole other topic we can look at, right? If we wanted to. We can look at beyond our solar system. Is that something we can do? Or is it just kind of very conceptual, it looks like? Interesting. Okay, nice. Let's go back to the article we were looking at. That was a nice little tangent, I would say. Right, full screen. We are all made of stardust. This may sound fanciful, but the reality is almost every element found on Earth was created in the burning core of a star. All the stuff that makes up life on Earth, therefore, our bodies are made of stardust. NASA have studied stardust extensively, and you can read more about their research on their official website. A NASA stardust canister is pictured above and doesn't show, so I will try to find it myself real quick for you guys. NASA stardust canister, if I can be so bold as to find it. And I did. Here we go. So NASA stardust canister right here. This is what it looks like. Very cool. Awesome. In the words of Carl Sagan, the nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff. And I have another cool little article that we can go through to learn more about space. And this is crazy facts. Crazy facts you didn't know about space. Supposedly. So, let's begin. Space is completely silent, despite what sci-fi movies and films might have you believe. With the pew-pews and the boom-booms and all that stuff, it is actually silent. There is no atmosphere in space, which means that sound has no medium or way to travel to be heard. I wish they would expand on this a little bit more, and since they won't, I will go take it upon myself to expand on it by finding some more information, because it kind of bothers me that there isn't enough info about that. It's just kind of like one sentence. So I will, and I'll spare you guys me doing this for every fact, but I think this one's kind of interesting. So I will do some research. Here we go. So, space is more silent than you could ever imagine, but it's not completely devoid of sound. That's why I wanted to double check on that, because there is some sound. I think it's just that we wouldn't be able to hear it through our human ears. Many will have heard the expression that space, no one can hear you scream, but like many others before you, you may have simply accepted this as the truth without thinking much more on the topic. But not us, guys. Not us. Did you know that there are more stars than grains of sand? Yes, I did know that actually. And I think that, how many stars are there? There are about, at least in our Milky Way, there's about 100 billion to 400 billion stars in our Milky Way. And grains of sand on Earth is about, how much? Yeah. It seems like we've got multiple stars for every grain of sand. So the grains of sand are actually nowhere near close to the amount of stars in the universe. So it's kind of crazy, right? It just goes to show how small our world actually is. We might act like our world is like all that there is, but we're just a tiny little speck in the universe. It kind of humbles you in a way if you really think about it. But yeah, that's a cool little fact, isn't it? Right? It really paints things into perspective. So where was I? So space is a vacuum, but what does that really mean? We know that things, we all know of this thing called space, but what exactly is it? To put it simply, space is everything that you can find outside of Earth's atmosphere. Despite being filled with stars, planets, asteroids, and so on, space is referred to as a vacuum. A vacuum technically means a space entirely devoid of matter. Inside a vacuum, there is absolutely nothing. No particles, no air, nothing. So how is space a vacuum if there are so many cosmic bodies filling the night sky? Well, it turns out that space isn't actually a true vacuum. It's referred to as such for convenience, as space is such a large place that the vast majority of it is actually a vacuum. But how does sound travel anyway? And why can't it travel throughout space? Like light, sound travels in waves. But unlike light waves, however, sound waves are referred to as a mechanical wave. In the case of sound waves, these mechanical waves come in the form of a vibrating wave that transports energy as it moves from one place to another. This wave has to travel through what we call a medium, which in this case is through particles. So let's look at an example, though, to make it a little clearer. If you play a string of a guitar, the string is going to vibrate. This initial vibration creates a chain reaction in the particles around it, in a way not too dissimilar to the ripples from a pebble dropped in a pond, right? You picture the pebble and hitting the pond, you see the little ripples in the water and such. Each particle affected then translates or transfers the vibrations onto those around it, transferring the energy. The further the sound wave travels, the weaker the vibrations become. This happens until the sound waves cease to exist, due to a small amount of energy being lost in each transfer between particles. So, for sound to travel, we need particles. These particles can make up a whole range of things, including water, gas, liquids, or even solids. Sound, it cannot travel through space, though, as it's a vacuum. So, if you played a guitar in space, you wouldn't hear it. If I was doing an ASMR video in space, you wouldn't hear me, right? It wouldn't be possible. So there are no particles in the enormous gaps of nothingness between cosmic bodies in space to vibrate, and thus the initial vibrations of the guitar string, they wouldn't have anything to transfer through and to, and so no one would ever hear it. So how can space be silent if it's not a true vacuum? While the vast majority of space is a vacuum, and thus completely silent, there are still some areas that can be heard. But doesn't this go against everything that we've talked about so far? Not exactly, really. Throughout the universe, clouds of dust and gas can be found. These can be the remains of long-dead stars, or even regions where matter is being pulled together to form a new one. In these spacefaring clouds, it's possible for the gas and dust to become clustered and thus dense. What this means is that it's actually possible for there to be enough particles close enough together for sound to occur, and to even travel a small distance. An example of where sound in space occurs is within black holes, but unfortunately it's impossible for humans to hear. This sound was first recorded in 2003 at NASA's Chandra X-ray Observatory. It came from the Perseus galaxy over 250 million light-years away. The sound was measured to be a B-flat, but at a frequency of billions of times lower than it is physically possible for humans to hear. So, is space silent or not? While space is more silent than you can imagine, it's not completely devoid of sound. Sound waves cannot travel through space, but there's some infinitesimally small regions where sound can exist under very specific conditions. And, even then, it might not be possible for us to hear it. It might not be humanly possible. So, I didn't know until now that the sunsets on Mars is blue. Let's look that up, shall we? Maybe there's some sort of concept picture that we can look at really quick to look at this. I got something here for us here. I will share my screen. Let's take a look. Here we are with sunset on Mars. Let me open this up into another image here. There we are. That's very cool, actually. I wonder why that is. Why does Mars have a blue sunset? That's what I want to know. Let's take a look. Let me take a look real quick. Why does Mars have a blue sunset? I don't know. Let's see. This is an NBC News article, so I might not be able to read it fully, but we'll see in a second. So, on Earth, the molecules that make up our atmosphere also partly block the sunlight. Mostly they scatter light around the sky, and they're much better at scattering blue light than red light. Their ability to scatter light falls off sharply as the wavelength of the light gets longer. So some blue light gets scattered out of the direct sunbeam and goes into the rest of the sky. But on Mars, there's much less of an atmosphere. In fact, if there weren't for the dust in Mars' sky, the sky would be nearly black. That dust, however, blocks light of all colors almost equally, and there's enough dust to limit visibility to about 20 miles. Since the dust is colored by iron rust, it absorbs the blue light and scatters the red light, giving the sky a rusty sort of color. On Mars, while the sky is red during the day, the sunset is blue. The reason for this is that the dust particles always make a blue halo around the sun on Mars. But the halo is only easy to see when the light passes through all the dust while coming over the horizon. So there you go. That's super fascinating. I didn't even know that, to be honest. I just find stuff like this so interesting because it's like we get so we're so in tune with the world around us, our world, that we forget how drastically different things could be on foreign planets. And you know, this is just in our solar system. Can you imagine in other galaxies, in different sections of the universe far away from ours, from our location, from our solar system? It's hard to even conceptualize. Leroy, how are you, my friend? I'm doing well. I'm doing well. I hope you're doing well on this Sunday. We've been reading some space/universe facts, going off on tangents and such. Enjoying some coffee on this Sunday afternoon. Happy to have you join us, man. Thanks for coming. Thanks for coming. Where was I? Okay. The hottest planet in our solar system is 450 degrees Celsius. Venus is the hottest planet in the solar system, and it has an average surface temperature around 400 degrees Celsius. Did you know that Venus isn't the closest planet to the sun? That's Mercury. You would think that Mercury would then be the hottest, but Mercury has no atmosphere, which regulates temperature, resulting in big fluctuations. This one's gonna blow your mind, guys. A full NASA spacesuit costs $12 million. $12 million, a whole suit. While the entire suit costs around $12 million, 70% of that cost is for the backpack and control module. However, the spacesuit that NASA uses were built in 1974. If these were priced by today's pricing, they would cost almost $150 million. Actually, you know, I didn't know that they were still using a spacesuit from 1974. That's not good. I mean, I don't know shit about, like, you know, what's required to travel into space, but I imagine updating the technology would be necessary for something like going to space, right? Am I British? I don't think I am. I don't sound British, do I? Is it because of this mug? Yeah. I used to date a girl that was British. I got a mug. My family actually gave me a mug. They thought it was funny. I think it's a nice mug though, so I drink from it. It's, you know, my favorite mug. I continue to drink from it, even though I don't date her anymore, because why not? I do like British culture though, so it works. Actually, the saying on this says "keep calm and carry on," which is like, it sounds like a generic white girl thing, but it's actually something Winston Churchill said during World War II, when England was getting bombed by Nazi Germany. So I thought that was pretty cool to find out. So, the sun's mass takes up 99.86% of the solar system. And we were looking at sort of like a Google Earth rendition of the universe, or of our solar system earlier. I can show you guys it in a minute if I can find it, but the sun is massive, right? That's the point, relative to everything else in our universe. In our solar system, excuse me. The sun accounts for 99.86% of the mass in our solar system, with a mass around 330,000 times that of Earth. the sun is made up of mostly hydrogen, with the rest of its mass attributed to helium. If the sun had a voice, would it be high and squeaky from all that helium? Probably. Our sun is actually very small, though, compared to some suns in, in the galaxy and the universe. That's the mind-blowing part, right? 1 million Earths can fit inside the sun. The sun is large enough that approximately 1.3 million Earths can fit inside, if squashed in. Or if the Earths retain their spherical shape, then 960,000 would fit. But can you even visualize that number of Earths? I don't even know how I would possibly do that. There are more trees on Earth than stars in the Milky Way. There are about 3 trillion trees on planet Earth and about 100 to 400 billion stars approximately in the galaxy. That's pretty cool. That I did not know. I knew the grains of sand thing comparing to stars, but I didn't know the trees thing, so that's pretty neat. You're from Chicago. Nice, nice. How is Chicago these days? I haven't been ever to Chicago, but I've always wanted to go and try deep dish pizza. That's my thing. I'm from New York, so like we know our pizza. But deep dish is kind of like a whole different experience that I really want to try. And I work for a company that has a lot of people from Chicago, actually. So it's possible I might visit sooner rather than later. So the storms on Neptune is so big that it can swallow a whole Earth. Oh, that's crazy. Let me see real quick. Hold on. Storms on Neptune. Let's look at it. If we can find let's see if we can find anything good, shall we, guys? I'm gonna share my screen real quick. Let's see. So, a dark storm on Neptune abruptly switching directions and started moving away from almost certain death, puzzling astronomers. It's just a picture, but usually these dark spots on Neptune live for a few years before either vanishing or fading away. However, the storm mysteriously stopped moving south and made a sharp U-turn, drifting back northwards. At the same time, astronomers spotted a second smaller dark spot on the planet. They theorized that this smaller cousin storm may be a piece of the original vortex that broke off and drifted away. That's interesting. We always think about like the storms that we experience on Earth, but can you imagine storms on other planets and what that would be like? I can't even like begin to conceptualize it in my head, Oh, look at this. The sunset on Mars appears blue. That's cool. This is what we were saying earlier. How to press. You were saying this earlier, that the sunset on Mars is blue. Just as colors are made more dramatic in sunsets on Earth, sunsets on Mars, according to NASA, would appear bluish to human observers watching from the red planet. Fine dust makes the blue near the sun's part of the sky much more visible, while normal daylight makes the red planet's familiar rusty dust color the most perceptible to the human eye. And we talked about this other fact too earlier. There's more stars in the universe than grains of sand on Earth. The universe extends far beyond our own galaxy, the Milky Way, which is why scientists can only estimate how many stars are in space. But scientists estimate the universe contains approximately 1 trillion stars, or a septillion. That's probably not trillion. I don't know how much that number is. It's a lot. While no one can actually count every single grain of sand on the Earth, the estimated total from researchers at the University of Hawaii is around 7 quintillion, 500 quadrillion grains. That is an awfully big sand castle. I learned some space facts in my science before I finished high school in your science class. Nice. in high school I took some physics classes, chemistry, but the only class I took where we kind of learned about the universe was an astronomy class, and most of the time we were just learning about like constellations and stuff. We would go into like we had like a planetarium, which was really cool, and we would go in there and we would look at constellations, but we really didn't learn anything about the universe or space for some reason. Our teacher was just obsessed with constellations for some reason. It was very strange. It was very strange. Have I heard about the New York hurricane? Yeah, it passed by already. It was last week, and our subway was kind of like devastated by it. If you go on the Instagram account Subway Creatures, you can see some of the flooding that was happening in the subway. It was pretty crazy. My area was fine for the most part. I just like had to close my window because a lot of the water from the rain was coming into my apartment. But aside from that, it was fine. But yeah, it was. I saw a lot of videos of people driving in water. Like there was a lot of flooding. It was pretty wild. One day on Venus is longer than 1 year. Venus has a slow axis rotation, which takes 243 Earth's days to complete. The orbit of Venus around the Sun is 225 Earth days, making a year on Venus 18 days less than a day on making a year on Venus 18 days less than a day on Venus. Excuse me. I got confused for a second there. There is a planet made of diamonds. There's a planet made of diamonds twice the size of the Earth. The Super Earth, aka 55 Cancri, I don't know how to say that, is most likely covered in graphite and diamond. Paying a visit to that planet would probably pay for the $12 million spacesuit needed to get there. I've been saying this for a while, Ray. I think that the only way we're going to get humanity invested in the space race again is either through competition, like, you know, Russia and the US. Russia's like, oh, we're going to do this, and then the US will respond. Or money, right? Like there's going to be some monetary reward for going to space. I don't imagine that we'll ever be able to truly go into space to our truest potential just by our curiosity, you know? I think we need this massive motivating factor to get us there, like the space race between Russia and the Soviet Union, between Soviet Union and the US. Unfortunately, you know what I mean? Like it sucks that it has to be that way, but we also have to acknowledge that's what motivates humanity currently, in our current point in our existence. So I'm Australian, so here in Australia we don't experience hurricanes. Yeah, but you guys do have like all sorts of crazy shit over in Australia, you know? Massive spiders, kangaroos, which I want to pet a kangaroo so badly, but I don't know if that would be a great idea. I hope everything's going well in Australia, though. Hope you guys have been handling the pandemic and everything as best as you guys possibly can. I don't really tend to talk about that stuff here because we just, you know, I want to take your guys' minds off of that stuff, but hope everything's going well. Yeah, Leroy, I'm American. I was born in Canada, and I grew up in New York, so technically I have a dual citizenship. Technically, I guess that would make me Canadian, but you know, grew up in America, in New York my whole life, so I guess in a way I'm Canadian American, American Canadian. My family is from Eastern Europe, so Slovakia and Serbia, so I've got some you know, mixed lineage there. I took like a DNA test, and I've got like background from Eastern Europe, Slovakia, Serbia, Romania, Poland, Slovenia, I think. I don't remember correctly, maybe. but you know, that Eastern European, Central European region. And somewhere in there, for some reason, I have like 1% Irish or something like that, I think. I don't know how the hell that happened, but apparently someone in my family was like, I'm going to Ireland for a little bit. Don't know. It's weird. I can speak very basic Slovakian. So, ja môžem rozprávať po slovensky, ale nerozprávam tak dobre, lebo ja som Američan. So basically what I just said is I can speak Slovakian a little bit, but I don't speak that well because I'm American. So, but môžem rozprávať po slovensky trochu. Nie veľa. So, I can speak Slovakian a little bit, but not a lot. I used to be very, very fluent when I was a kid, right? Like I recently watched an old video of me opening up presents on Christmas from like 20 years ago, 2000, Christmas Eve 2000. I was like 9 or 10 at the time, something like that. And I was just like talking so fluently. I was like, oh my god, I forgot some of those words existed. And I also had a really thick accent too. I sounded like I was from a foreign country. It was weird because my first language was actually Slovakian. It wasn't English because my parents didn't speak English at the time. So I learned Slovakian first, and then I learned English by going to school. So over time, obviously, I live in America, so you know, you speak English more and more and more, and there isn't really a community here of Slovakians, so you kind of just speak English for the most part. My family all speaks English, so I've forgotten so much Slovakian that I kind of just, I'll start speaking in Slovakian and fill in words with English. It's just the way that it is, you know. Let's dive back into some of this stuff. I work in a game store called EB Games, but it's closed right now, so I basically have a holiday. Nice. Well, I hope you're enjoying your holiday, man. I know EB Games actually. I used to shop there actually when I was a kid. I got a lot of games from EB Games. That's interesting. I didn't know such a massive store. I thought it was just like a local thing. That's interesting. I used to love getting games from there. EB Games, GameStop, a bunch of local areas, local stores that I would buy games from. So, there is a supermassive black hole at the heart of every galaxy. Let me show you guys some black hole action real quick. We got a black hole right here. Not a real one, obviously, just conceptualized, but it's cool. Active galaxies often pump out 100 times more light than a normal galaxy. With the discovery in 1963 of quasars, it was clear that the light comes from not stars, but from a central region smaller than a solar system. The only conceivable energy source is matter heated to incandescence as it swirls down onto a giant black hole, up to 50 billion times the mass of the sun. And oh, by the way, guys, since I have you guys here and I have your undivided attention, two things. What would you like me to stream more of from on the ASMR channel? I'm going to stream during the week as well. I'll try to stream more often. And second point, if you haven't already, follow me on twitch.tv/Valdar91, VALDAR91, Valdar91. If you want to watch me stream some games and chill with me in a normal context, I stream Dead by Daylight, I stream, I'm going to stream some Dark Souls as well, and whatever I find interesting. So, just those 2 points. In the 1990s, NASA's Hubble Space Telescope found that although active galaxies account for only 1% of galaxies, supermassive black holes are no anomaly. almost every galaxy, including our Milky Way, contains one but starved of a food supply. Most have switched off. What are supermassive black holes doing in the hearts of galaxies? Were they the seeds around which galaxies congealed, or did newborn galaxies spawn around them? These remain some of the biggest unsolved questions in astrophysics. And one of the cool things I've always thought about is like, what happens if you can successfully go into a black hole? You know, I imagine realistically, you just get completely pulled apart and disintegrated into nothingness and you die. But let's say you could go through the black hole. What happens, right? Like, what's on the other side? Does it just take you into another part of the universe? Is it like a portal of some kind? What is it? You know, what does it lead to? Is it just an endless, loop of nothingness and you just never get out of it? What would happen? Which I guess we can look that up, right? Let's see what the theories are. What would happen if you could go into a black hole? Let's see. Right now it's 3:50 in the morning for me, so I'm gonna go to sleep. Have a great rest of your day. Thank you, Out of Press. Thanks for tuning in, my friend. I'm really glad you're able to make it. Have a good night. Have a good sleep. I'll see you around. Resident Evil Village. Oh, that's a good one. I don't have it. I can play that one as well on my channel. That'd be fun to play. There's a lot of games that I play in my day-to-day that I could also play on stream. Because the thing is, like, the reason I decided to start streaming video games on Twitch is because I'm already gaming in my free time, so I might as well, stream and have fun with it. See if I get like an audience on Twitch. Okay, so here is what would happen. Black holes are expected to form when a massive star dies, not a black star, what am I saying? After the star's nuclear fuel is exhausted, its core collapses to the densest state of matter imaginable, 100 times denser than an atomic nucleus. That's so dense that protons, neutrons, and electrons no longer discrete particles. Since black holes are dark, they are found when they orbit a normal star. The properties of the normal star allow astronomers to infer the properties of its companion, a black hole. The first black hole to be confirmed was Cygnus X1, the brightest X-ray source in the Cygnus constellation. Since then, about 50 black holes have been discovered in systems where a normal star orbits a black hole. They are the nearest examples of about 10 million that are expected to be scattered throughout the Milky Way. Black holes are tombs of matter. Nothing can escape them, not even light. The fate of anyone falling into a black hole would be a painful spaghettification, an idea popularized by Stephen Hawking in the book A Brief History of Time. In spaghettification, the intense gravity of the black hole would pull you apart, separating your bones, muscles, sinews, and even molecules. As the poet Dante described the words over the gates of hell in his poem, Divine Comedy, abandon hope, all ye who enter. Is that a plane? I guess no one's really like theorizing what could happen if you go through it, or what could potentially be on the other side of a black hole. Let me look that up though. Well, what could be on the other side of a black hole? That's what I think I want to know, right? What is on the other side of a black hole? I don't want to know like what would happen, because we can kind of assume, right, that we would just die, but where would we go? Let's see. Ever since Albert Einstein's general theory of relativity was considered to have predicted black holes by linking space-time with the action of gravity, it has been known that black holes result from the death of a massive star, leaving behind a small, dense remnant core. Assuming this core has more than roughly 3 times the mass of the Sun, gravity would overwhelm to such a degree that it would fall in on itself into a single point, or singularity, understood to be the black hole's infinitely dense core. The resulting uninhabitable hole would have such a powerful gravitational pull that not even light could avoid it. So, should you find yourself at the event horizon, the point at which light and matter could only pass inward, as proposed by the German astronomer Karl Schwarzschild, there is no escape. I know that, but I want to know what would happen. You know? I want to know what would happen on the other side of this black hole. By the way, I just want to share this with you guys because it looks cool. So this is like a black, hungry black hole of stuff. Hubble Space Telescope observation of active galaxy. Neato. There we are. Black holes. They're considered to be starving as there's insufficient gravitationally captured material to feed them regularly. But over the years, scientists have looked into the possibility that black holes could be wormholes to other galaxies. They may even be, as some have suggested, a path to another universe, and that's what I was thinking, right? Like, what if it leads to another universe? Such an idea has been floating around for some time. Einstein teamed up with Nathan Rosen to theorize bridges that connect 2 different points in space-time in 1935. But it gained some fresh ground in the 1980s when physicist Kip Thorne, one of the world's leading experts on the astrophysical implications of Einstein's general theory of relativity, raised a discussion about whether objects could physically travel through them. Reading Kip Thorne's popular book about wormholes is what first got me excited about physics as a child. It doesn't seem likely that wormholes exist. But the problem is that we can't get up close to see for ourselves. We can't even take photographs of anything that takes place inside of a black hole. If light cannot escape their immense gravity, then nothing can be snapped by a camera. As it stands, theory suggests that anything which goes beyond the event horizon is simply added to the black hole. And what's more, because time distorts close to this boundary, this will appear to take place incredibly slowly, so answers wouldn't be quickly forthcoming. I think the standard theory is that they lead to the end of time, said Douglas Finkbeiner, a professor of astronomy and physics at Harvard. An observer far away will not see their astronaut friend fall into the black hole. They'll just get redder and fainter as they approach the event horizon as a result of the gravitational shift. But the friend falls right into a place beyond forever, whatever that means. This is an artist's concept of a wormhole. If a wormhole exists, they might lead to another universe, but there's no evidence that they're real or that a black hole could act like one. But I think it's an interesting theory. If black holes do lead to another part of a galaxy or another universe, there would need to be something opposite to them on the other side. Could this be a white hole? A theory put forth by Russian cosmologist Igor Novikov in 1964. Novikov proposed that a black hole links to a white hole that exists in the past. Ooh. Unlike a black hole, a white hole will allow light and matter to leave, but light and matter will not be able to enter. That's very interesting. A white hole would be in the past, is, like, wouldn't we be able to see that in our observable universe too? Because they're saying the white hole is a theory. I've never heard of a white hole, so scientists have continued to explore the potential connection between black and white holes. In their 2014 study published in the journal Physical Review D, physicists Carlo Rovelli and Hall M. Haggard claimed that there is a classic metric satisfying the Einstein equations outside a finite space-time region where matter collapses into a black hole and then emerges from a white hole. From a wild hole. I think it's a typo, but in other words, all of the material black holes have swallowed could be spewed out, and black holes may become white holes when they die. Far from destroying the information that it absorbs, the collapse of a black hole would be halted. It would instead experience a quantum bounce, allowing information to escape. Should this be the case, it would shed some light on a proposal by former Cambridge University cosmologist and theoretical physicist Stephen Hawking, who in 1970s explored the possibility that black holes emit particles and radiation thermal heat as a result of quantum fluctuations. So, all that to say, it is a very fascinating topic that, you know, this idea that you can go through a black hole and you would end up in another part of the universe, or in the past, or in the future. To me, it's interesting. You know, that's all I'm saying. So, the universe has the same temperature everywhere. The heat of the Big Bang fireball was bottled up in the universe. It had nowhere to go, so it is still around today. The weird thing is that its temperature is minus 2.725 Celsius, above absolute zero. The lowest temperature possible is essentially the same everywhere. Yet, if we imagine cosmic expansion running backwards like a movie in reverse, we find that parts of the universe that are on opposite sides of the sky today were not in contact when the fireball of radiation broke free of matter. In other words, there has been insufficient time for heat to travel between them and the temperature to equalize since the universe's birth. Astronomers fixed this by maintaining that early on the universe was much smaller than expected, so heat got around easily. To get from this smaller size to its present size, the universe had to go through an initial burst of super fast expansion known as inflation. 95% of the universe is invisible. Take a sip of water here. There is a discovery so amazing that it has yet to trickle into the consciousness of most working scientists. Everything science has been studying these past 350 years is but a minor contaminant of the universe. Only about 4.9% of mass energy of the universe is atoms, the kind of stuff you and me are made of. About 26.8% of cosmic mass energy is invisible dark matter, revealed because it tugs with its gravity on the visible stuff. Candidates for what makes up dark matter include hitherto unknown subatomic particles and black holes made in the Big Bang. But in addition to the dark matter, there is dark energy, accounting for 68.3% of mass energy of the universe. It's invisible, fills all of space, and is accelerating cosmic expansion. And our best theory, quantum theory, overestimates its energy density by a factor of 1 followed by 120 zeros. The universe was born. The universe has not existed forever. It was born. 13.82 billion years ago, all matter, energy, space, and even time erupted into being a titanic fireball called the Big Bang. The fireball began expanding, and out of cooling debris there was eventually congealed the galaxies, great islands of stars, of which our Milky Way is one among an estimated 2 trillion. This, in a nutshell, is the Big Bang theory. Whatever way you look at it, the idea that the universe popped into existence out of nothing is utterly bonkers, but that is what the evidence tells us. An immediate question arises: what happened before the Big Bang? The reluctance to face this awkward question is why most scientists had to be dragged kicking and screaming to accept the idea of the Big Bang. And like I was saying earlier, I like this idea of like parallel universes, you know, 2 parallel universes existing side by side, right? Parallel universe A, parallel universe B, and they collide, and that gives birth to, let's say, our universe. Of course, like I said earlier, this also goes into this whole question of, okay, but what about those 2 original universes? How did they come into existence? And you know, you get into this whole chicken and egg thing, and it goes on and on and on, and you never really can get to the beginning of it because no one freaking knows, right? But yes, like they're saying, the dominant theory is that the universe started with the Big Bang. That's the evidence that we have, and we don't have anything to the contrary of that, right? Everything else is just kind of speculation. So what happened before that? No one knows. How would that possibly happen? No one knows. So most of the stuff in the universe has repulsive gravity. The universe is expanding, its constituent galaxies flying apart like cosmic shrapnel in the aftermath of the Big Bang. The only force operating should be gravity, which acts like a web of elastic between the galaxies, slowing them down. But in 1998, contrary to all expectations, astronomers found that the expansion of the universe is actually speeding up. To explain it, they postulated the existence of invisible stuff, which they've termed dark energy, that fills space and has repulsive gravity. It is the repulsive gravity of this dark energy that is accelerating cosmic expansion. Dark energy accounts for almost 2/3 of the mass energy of the universe. School science is therefore behind the times in saying that gravity sucks. In most of the universe, it blows. The sun is producing only 1/3 of the neutrinos expected. Hold up your thumb. 100 billion neutrinos are passing through your thumbnail every second. 8.5 minutes ago, they were in the heart of the sun. Solar neutrinos are a byproduct of sunlight generating nuclear reactions. When Ray Davis set out to detect them with 100,000 gallons of cleaning fluid down a mine in South Dakota, he expected to confirm the standard picture of the sun. Instead, he found only 1/3 of the expected neutrinos. That was not only confirmed by later experiments, but led to his Nobel Prize. Neutrinos are ghostly subatomic particles existing in a weird quantum superposition akin to an animal. That is simultaneously a cow, a pig, and a chicken. As they travel from the sun, they flip between an electron neutrino, a muon neutrino, and a 2O neutrino, which is why experiments sensitive to only one type pick up 1/3 of the expected number. Most planetary systems are different from ours. Scientists hate to invoke anything special about our situation in the universe. Special is improbable, which typical is probable, while typical is probable. But the discovery of planets around other stars at last count, more than 3,500 have been confirmed, has created a headache. None is like our own. There are super compact planetary systems in which planets orbit closer to their parent star than Mercury. the innermost planet of the solar system, does to the Sun. There are Jupiter-mass planets that must have migrated inward. There are planets in highly elliptical orbits similar to those of comets, and there are planets that orbit the wrong way around their stars. Given that planets are believed to be to congeal from gas and dust swirling in the same direction around a newborn sun, this latter discovery is especially hard to explain. As of yet, nobody knows whether the unusualness of our solar system has anything to do with the human race having arisen to notice it. The first gravitational waves detected came from a binary black hole system nobody predicted. Let me check my stream real quick, make sure everything's good. Okay, I got paranoid that it wasn't recording. On September 14th, 2015, gravitational waves were detected on Earth for the first time. These ripples in the fabric of space-time predicted by Einstein in 1916 came from the merger of two black holes in a distant galaxy. Briefly, the power pumped out was 50 times greater than that of all the stars in the universe combined. But this was not the only jaw-dropping aspect of the event. Nope. Each of the black holes was in the 30 solar mass range. Since a black hole is what's left after most of a star has blown into space as a supernova, the precursor stars must have weighed at least 300 solar masses. Such stars are incredibly rare today, but the two black holes could have been remnants of the very first generation of stars, thought to be huge or even primordial black holes, born in the inferno of the Big Bang itself. We appear to be alone. There are approximately 100, whatever this number is, stars in the universe. A lot of stars. Whatever this number is. And probably more planets than stars. Yet, in all this immensity, there is only one place we know of where life exists: Earth. Despite searches for intelligent signals, no signs of intelligent extraterrestrial life has been found. In fact, there is a good argument that if such life forms exist out there, not only should we see signs of them, but they should have already come here. Where are they? The physicist Enrico Fermi famously asked. I like how that's like a famous quote. Where are they? You know, dude's just sitting in his like lab doing research, and he's like, fucking, where are they? You know, like, if they're here, where the fuck are they? Some astronomers think the answer is we are alone, that someone has to be the first. But the absence of evidence is not evidence of absence. It took 3 billion years for us to go from single cells to complex life, which suggests taking this step is hard. Technological civilizations like ours may be rare and their lifetimes short. We may have missed any others by millions or billions of years. The other alternative is that the nearest one may simply be too far away for us to detect. And, you know, that is kind of what I was saying earlier, right? It's like, just because we don't know of other civilizations doesn't mean that they don't exist, you know? It's very arrogant to say that we are the only intelligent civilization in the universe, because we don't know that. There could be so many more, you know? The possibility of life in our galaxy is astronomical, so who knows what's out there. But I digress, my friends. It has been 2 hours into the stream. I think that I'm going to call it here. Nice little 2-hour stream. For those of you who were able to make it today, thank you very much for coming to this stream. I hope you had fun, and I hope you enjoyed learning for 2 hours about the universe and space. I think that I will make a habit of streaming more often. It was fun. More people actually showed up than I thought were going to, if I'm going to be honest. I didn't think I was going to get that many people dropping in and chatting, so based on that fact alone, I am going to try to stream more often. I'll try to stream on Sundays, I'll try to stream during the week. They'll be spontaneous because I don't know what my schedule is going to look like. Sometimes I have a lot of work to do at my job, and so I'm more tired. But I will be trying to stream regularly on Twitch, on YouTube, doing different kinds of topics. I'll have to think about some stuff. As I've mentioned, ASMR is a different sort of medium for streaming. People don't necessarily want to interact. They want to just, have it on in the background and listen. So I will be doing that more often. And of course, I am also streaming on twitch.tv/Valdar91, streaming video games, Dead by Daylight, Dark Souls, etc. So if you can join me there, that's great. And if not, feel free to stop by my ASMR streams here on YouTube. Thank you guys for tuning in. I hope you learned something. I hope it was relaxing. And as always, I will see you in the next video, my friends. Thank